So, unfortunately, Christian, who made the master's thesis about selective deletion in images, is ill, and he asked me as his advisor for his master's thesis to give the presentation. So please apologize that I shortened the presentation in the detailed technical part, and that I got some notes with me. It was a spontaneous thing that I'm now the presenter of this presentation. A short outline. After an introduction, we will have a look at selective deletion, a wider look at the evaluation, and then a short conclusion. The motivation of this master's thesis was just to give you some background. I'm working at a police station in Darmstadt as computer forensic examiner. Was motivation for this thesis was that in law enforcement investigation, the search and seizure of digital evidence is a standard procedure, as we already have heard this morning from Martin. And normally a bitwise copy is created of the digital evidence. Even Martin said this morning, if the reason of the investigation is a non-cybercrime, is of non-cybercrime nature. I talked to a judge on Monday who is responsible for all crimes resulting in death, like murder and so on, and he said that in most cases, up to 90%, the digital evidence is significant for the court. Martin already mentioned some problems arising to law enforcement agencies. It's the mess data or mess of data, the needle in the needle stack. We heard this morning. A possible solution is selective imaging, but this is not the topic. And we face more and more specialized defense counsels. What does this mean? I will show you on the next slide. And possible solution is selective imaging or the selective deletion. We already heard some buzzwords like wiretapping in the talk of Martin and in the talk of Daniel Spiekerman. But what does wiretapping has to do with selective deletion? A lot. Because the legal considerations for wiretapping and for the storage and seizure of digital evidence are in the German law very similar. The first decision in this point was made by the German Federal Constitutional Court in 1957. The so-called Elfes decision was the first decision which limits the access and the usage of private information. And this for wiretapping and normal digital evidence in German law. So what does this mean? The quintessence of all the privacy data laws and privacy data acts in the US is that law enforcement is forced to spare out the blocks of irrelevant data to the case. Is forced, but if it's done, this is another point, we'll come to that later. If this cannot be done while the imaging process or the acquisition process, the deletion has to be applied as soon as possible, and the documentation of the deletion is mandatory. Sparing out the blocks during the acquisition process or even the deletion after the acquisition process is not a common practice in the German law enforcement agencies. There are several reasons why this is not a common practice. The first reason you will hear if you talk to some law enforcement investigators is the deletion of data modifies the image you have created from the evidence. And the second is that the image afterwards may be not accepted in court. Just to give you a short example, just imagine you have a blog server hosting hundreds of blogs, and you are in a law enforcement investigation. You get to the server. Normally, forensically correct will be the seizure of the server, but nobody wants to seize a server and then put it on the what's the word, LKW. The normal procedure would be imaging directly in front of the server. But what happens if you image the whole server. You get a lot of case-irrelevant data, especially the data from the innocent bystanders if the block server hosts hundreds of servers and only a few of them are involved in illegal activities. Which questions do arise? In the German law, the deletion afterwards, as I told before, but how do you have to delete this data? The normal deletion of files, as everybody knows of you, is in the middle. Deletion by instructions implemented in OS. This is not a real deletion, only the index is modified. The second possibility would be wiping, zeroing out of the content of the physical allocated blocks of the data. But we stated that even the metadata still yields enough information to get non-relevant information about one's privacy and one's private life. The first thing is that no common forensic tool on the market exists which allows directly modifying or deletion in images. And that's why it is a forensically sound software. To extend this example to the metadata point, think about that there is some private data stored on that blog server, maybe some pictures of holidays in a directory structure like holidays 2017 Überling and holidays 2018 in Florence. And even if you delete the content of the data, you may get some information about one's private life. Out of the metadata, maybe you know where the person was in 2016, 2017, 2018, whatever. Two problems arising with metadata or with data and metadata is how to classify which data is relevant or not. Martin said that already, that this is just a human thing. There is no tool that says this data is relevant or not. And the second thing is how to delete this data, this non-relevant data in the images without affecting all the other data on the image. To get to guarantee the integrity of all the other data. So the definition, our definition of a forensically sound selective deletion would be with respect to the law that private non-relevant data has to be deleted. The integrity of the residual data has to be guaranteed. In a technical point of view, the deletion or the wiping out of the physical allocated blocks of the data has to be done. And our additional requirement or demand is that all the metadata that may yield information about one's private life has to be deleted too. So let me say a few words to Christian's master's thesis, his task force to investigate whether a secure selective deletion tool is technically achievable or not. You realized this task as a plugin for the digital forensics framework. You see it on the slide. Unfortunately, the DFF site goes down last week. And we bounded this plugin to Microsoft's NTFS system because we wanted to focus first on one operating system and on one file system to during this implementation of the selective deletion tool, some more functionality, and not only the deletion module was implemented. One module was the detection of duplicate files, which are not necessarily flagged. There will come to the point that the search and checking, flagging of relevant data is a human procedure, and you know that, or in normal cases, a human would ever skip one file or not. You won't get all files in your investigations. The second module, or the second part of his implementation, was a basic partition table parser, because the origin partition table parser of the DFF framework was corrupt. Another module was the detection of carved files, the so-called carver cleaner, which managed to show carved files from a former format of the device. The second or next was the hard link detection to prevent if more than one file is linked to the same content that the residual data is integer. Then the calculation of hash trees, and to that point we will come later. This is for the integrity checks. This is just a short overview about the deletion module. I said it in the introduction that I'm not so familiar with his technical implementation. The main module is the deletion module. Besides the zeroing out of the content of the allocated data blocks for the selected data objects, the deletion module realized the deletion of the metadata. If you have a look at the MFT entries, it is not possible to zero them totally out, then you will get the image in an incorrect state. So the MFT entries, especially with regard to fix-up values, have to be modified in a special way. If you modify the NTFS system and delete some folders or files, especially folders, the normal B-tree structure would be corrupt. So another part of the deletion module was a B-tree update. It is written down that there's some different things. If the deleted object is on the leaf level, there have to be other routines that if the deleted data object is on the mode level, but at that point let me refer to Christian please for the technical details. The hash calculator module was implemented to guarantee the integrity of the residual data. To wrap that up with the hash calculator module, two Merkle trees were calculated, one before the deletion and the second after the deletion, and the comparison of the two hash trees should show the same modification as the log file which was created by the deletion module. Just to give you a short overview about the evaluation. For the evaluation, there was an experimental setup with two scenarios. The first scenario was set up to show the correct functionality of the implemented plugin. It consists of 7 various test cases. In some test cases, directories were deleted. In some test cases, files, resident and non-resident files were deleted. And another test case was a reformatted device to show the correct functionality of the cover cleaner module. And 2 of the test cases were with bootable Windows to show that the B-tree update works correctly. The second scenario was the comparison against an existing implementation of professional software, in this case X-Rays Forensics. We set up a USB sticks with many directories and cloned or duplicate files in different directories, deleted one whole folder and the duplicates of the files in this directory on the total image. The evaluation of the first scenario showed the correct functionality of the implementation without major problems. The data content was erased, the B-tree update was managed properly, and the image disk, or the image and the disk were mounted properly, and even the Windows partition could be booted. There was one exception in the Windows partition. We tried to delete the user's home directory, and after booting up the Windows, a pop-up popped up. With a warning that the Windows is broken, and the user directory was created by Windows, but there was no data in it, just the Windows directory. And afterwards, the Windows worked correctly. We cross-checked that against other tools, against the FTK imager or in Hexdump, that all metadata and all data content, the physical allocated areas, were zeroed out. The second scenario was another test setup. First, both tools could find all duplicates. The Pro software deletes the files by sparing only the data content. So the metadata is still usable, even the full names were found. So the Pro software did only zeroing out of the data, of the physical allocated data blocks of the selected data objects. The input image was not modified in the Pro software because I said it before, no Pro software, Pro forensic software is able to modify images. X-Rays in that case created a so-called cleansed image out of the original image. And so, yeah, all what NCase does was this: the marked entries are deleted by only skipping these file contents during the copying process. In comparison to that, our tool operates directly on the image. As I said, there is no original image and a cleansed image. You only got one image, and if you delete something on this image, it's gone. So be careful. If you use it, you can use it. And we did a further verification of the correctness of these two evaluations with FTK imager and Hexdown to show that the implementation worked well. Just to show it to you on a slide, on the top you see the original image. Who knows X-Rays knows that this is familiar to the one you see on the X-Rays page. X-Rays only spares out during the copying process the blue blocks, the file content of file C and the file content of file A, and the selective deletion plugin for DFF not only spares the content blocks out, and even the MFT entries are modified. So let me directly come to the conclusion. Christian showed in his master thesis that a practical approach of a prototypical selective deletion tool is possible. All of our legal requirements and our additional requirements demands were fulfilled by this tool. That not only the relevant physical blocks of the data, the file content was wiped, deleted, even the metadata was wiped, unrecoverable, wiped. The residual data stays in an untouched way. With the usage of the hash calculation trees of the Merkle trees, the verification of the data integrity is guaranteed, and the continuous logging of every single step is the documented, other documented logs. That leads me to the last thing and to a problem. The logging while the deleting could also reveal information about the bystanders. But everybody knows we should do documentation logging, and so maybe we should keep the log files away from the image. So that's all for questions. Please contact Christian. The tool. Thank you. Just one more word. The tool may be available from now on. I don't know. Maybe next week on this homepage.
All right. Thank you, Konstantin. Do we have any questions?
I might have two questions in one. You already expected that. If I'm working in forensically sound manner, all of my steps needs to be auditable by a third person. So if I do a deletion out of the image, I need to maintain the image that the step can be audited. If I do not conduct logging, so that is some kind a paradox.
Yes. It is, yes, of course, but this is the same problem with wiretapping. If you have an investigation and you do wiretapping, you have to delete it from the record on the tape, and you write down what you deleted or what timestamp you deleted, and you didn't have the original. So yes, it's not forensically sound. It's not repeatable. This is the point, yeah.
And the second part would be, I have to search for the allegations and to relieve the suspect. So if I delete parts where I say, as an investigator, that has nothing to do with the case, I expect that the defender in court would stand up and say, okay, you maybe deleted evidence to relieve my suspect. Proof for that it does not happen.
The first point is that the court has to rely on you, that you don't delete any relevant data. Maybe I think the tool is for the storage in the law enforcement agency itself, not for the court. It's not to delete special data and give the image or the device back to the suspect. It is for the storage if you have to delete private data, like in wiretapping acts. But it's forensically,
Thank you.
Any other questions?
Let me first say that I find the Merkle tree solution very elegant, but I was wondering if for the chain of custody requirements it would be enough to just do that afterwards, or if you would want to create the Merkle tree root already at acquisition so that you have the forensic chain product.
You calculate two Merkle trees, one before the deletion and one after the deletion. And this is a deletion directly on the image, so normally if you have an investigation, you calculate MD5 SHA-1 hash.
My question was if that's sufficient for carving the chain of custody, or if you should already calculate the Merkle tree root when you're acquiring your image.
No. During the acquisition, you just calculate normal hash values with the tool of your choice. And this is just another Merkle tree. It's just for the image. It's not for a device, it's really for an evidence file image or expert witness image or whatever. So, not during the acquisition, another hash.
Any other questions?
Question, which side effects are to expect? As I understand right, there is no effect on the log file, on the journal, and nothing relevant on the registry. But how about the effect of the tool itself?
About traces from the tool in the image?
Yes.
There are no traces.
No traces.
I think there are no traces. Yeah. We haven't seen any traces in our evaluation. Yeah. There's not there are no traces. Yeah.
Any other questions? Hans?
So I can see that this would work for complete files, and servers which have database applications probably are not a good target. And for personal computers, I think it would work good. But the registry might, of course, contain all kinds of privacy-related information. Do you have did you think about a solution for cleaning up the registry?
No, about these data or metadata, no. Even on internet history, on the Explorer, no. Just thought about the MFT entries and this kind of metadata.
Thank you.
In the back?
One question, during wipe out the private data, how do you handle the slack space? Do you also wipe the slack space?
That's a good question. Christian? No, I'm sorry. I can't answer this question about this slack space. I don't know. I'm sorry.
Okay. Thank you very much, Konstantin. Let's give him another.